I'm a professor at Schweinfurt Technical University, or University of Applied Sciences, Würzburg-Schweinfurt, in the Faculty of Mechanical Engineering. And there I do teach engineering mechanics, vibration, machine dynamics, as we call it, fatigue, and design of experiments. Well, this design of experiments, I came in contact to it while I was in industry, in the printing press manufacturing industry, where we did physical experiments that were quite costly. So it was mandatory to get the best out of as little or as few experiments as possible. So it wasn't a deal of big numbers, but a reduced number of test runs and get the most out of it. And this is also my sort of bringing up, that I really love physical testing, hands-on on machines and test rigs, etc. And this is where the methodology is very, very helpful. Of course, I have to touch it because this becomes sort of mainstream with the advent now of very powerful simulation possibilities. One can do experiments on the desk rather than in the field. But I'm rather critical towards that because when you have a simulation model with certain assumptions in it, you will never get results that are outside of this box, as you might put it. But of course, when I do the teaching of design of experiments, we have a wooden catapult where one can throw little projectiles and determine how far they are thrown, determined by the factors. I do also do that virtual with a simulation model as a sort of comparison. And I have to do both, and I do both, but my heart beats for the wooden catapult, for the hands-on experiments. Yeah, this is what we do to find out the factor which has the highest impact or biggest contribution. We do a mathematical regression after we fit the data that we found from the experiment to a polynomial, and then with using the Cornerstone software you can find out which of the factors and the coefficients contribute most, so which are significant and which are insignificant. So this is also very important.